Today we are finishing Chapter 6. The last section for Chapter 6 is 6.7. It's all about scientific notation. It's a little bit different than the things we've been doing with exponents, but it does revolve around exponents, so that's why I stuck it in at the end of the exponent lessons. So our goal today is to write numbers in scientific notation from standard form and vice versa. So scientific notation is the new way we're going to learn to write numbers today, and then standard form is just normal numbers, the typical way to write numbers. So we're going to first start with regular numbers, write them in scientific notation, and then I'm going to give you scientific notation, you're going to give me the regular numbers. So scientific notation is the way that scientists easily handle very large numbers or very small numbers. So what's a big number? Like, yeah, what were you talking about when you were doing this? Conversions, okay. I always think of like outer space.
We don't like speeding with this sometimes.
Okay, and you did scientific notation with that? Okay. Yeah. Good. I like it. I like it. So yes, you'll see this a lot in science. I know my juniors are working a lot with it now in physical science. So you will encounter it. But I always like to think of it as when you're dealing with really, 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 really big numbers or really, 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 really small numbers. So let's say you're talking about the size of an electron or something. And it's like 0.000000000002 or something like that. If you're a scientist and you're doing calculations with a number like this, it would be very easy to forget a zero, right? Every time you'd write it out, you'd have to count up all those zeros. Same thing if you're talking about, let's say, the distance from here to Pluto. I don't even know what that is, but let's say it starts with a 5 and it has a whole bunch of zeros. This is not accurate at all, I'm just saying. Think if you're doing calculations with these numbers, how easy would it be to just drop a zero? And then your calculations from there on are just completely off. So the way scientists deal with these really, 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 really big numbers or these really, 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 really small numbers is to write them in scientific notation. So scientific notation has a number between 1 and 10. So we can practice on this one that I wrote. So if I would 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'll show you this in a second. So if I wanted to write that number in scientific notation, that's how I would write it. And I'll explain this a lot more on the next slide. But scientific notation is a lot easier because instead of writing 0, 0, 0, 0, 0, 0, 0, 0, let's say you have to write that 10 times in some calculations you're doing. It's going to be pretty easy to make a huge mistake, right? But if you're writing 10 to the 12th power instead of all those zeros, it's a lot harder to accidentally write an 11 than a 12, right? That's a lot harder than just, whoops, I forgot a zero. So that's what scientific notation is used for. Really, really big or really, really small, usually in the field of science, hence the name scientific notation. So there's two parts to scientific notation. There's a number between 1 and 10, a multiplication symbol, and then 10 to some exponent. Any questions about what we talked about so far? We'll get into exactly how you do it in a second. That's just a quick example and why we learn this. What's the point? Alright, so this should all be written out in your notes so you can just follow along either on the board or with the copy that you have right in front of you. This is how we're going to write a number in scientific notation. The first thing you want to do is move the decimal point so that it is right behind the first number. You're going to write that new number followed by times 10. Now, I always tell you don't use the X for times. Guess what? In scientific notation, it's completely acceptable. This is the only time I ever use the multiplication X as the times symbol. But it's okay. For some reason, I still see it all the time in scientific notation, but you never see it anywhere else. So this is fine. You can use a dot if it makes you feel more comfortable, but this is fine for today. So after you write the new number followed by times 10, You count the number of jumps it took you to move the decimal to its new position, and you make that number your exponent. So it sounds kind of tricky, but let's jump into some examples. So here's number 1. Every number that we're looking at, every whole number, has a decimal in the back. We just never write it. But if you had to put a decimal with that number, you'd put it behind the ones digit. So I'm putting a decimal right there. For scientific notation, I want it to be right after the first number. So I want to move the decimal to be between this 4 and this 1. So 1, 2, 3, 4. So my new number is 4.1214. We're just moving the decimal up. Always followed by a times 10. And then this is how many jumps you had to make. I had to make 4 jumps to move the decimal from here to up here. That's scientific notation. It's very similar to what we looked at in our warm-up because this number tells you how many zeros you'd have if you'd multiply this out. 10 to the 4th power is really a 1 followed by 4 zeros. That means you'd have to move the decimal 4 places to do the multiplication, which is what we had in the first place. It's just another way to write this number using multiplication and a product of 10. What are your questions? All right, same thing in the back. So where is the decimal right now? In the back. Where do I want it to be? Behind the 5, behind the first 5. So 1, 2, 3. That's 3 jumps. You got to remember that. So 5.256 times 10 to the 3 jumps. 3 is your exponent. So his question is, how do you know how many jumps you want? You want this first number to be between the numbers 1 and 10. The way we do that is you just put it right behind the first number. If you put it up here, your number would be smaller than 1. If you put it behind the 2, your number would be 52. That's greater than 10. The way to ensure that it's between 1 and 10 is to put it right after the first number. So you just count the jumps. 1, 2, 3 jumps. 3 is the exponent. Questions? All right, let's jump to the next jump. Haha, lots of jumping. Jump to number 3. So the decimal starts behind the 2. And how many jumps? 3. 1, 2, 3. I want it to go behind the 6. So 6.142 times 10 to the 3rd power. All right, same thing on the next one. Where is the decimal now? Where do I want it to go? Between the 9 and the 1. So 1, 2. So this is going to be 9.15 times 10 to the how many jumps? 2. Questions? You will see this multiple times in science and math over the next couple years, so just remember it as you go. So number 5, where's the decimal? That's where I want it to be. Right now it's back here. So 1, 2, 3, 4 jumps. Any questions? All right, this next one, honestly, I don't know why anyone would write 36 in scientific notation, but hey, let's practice anyway. So right now it's behind the 6. Move it 1 space. So what's my exponent? 10 to the first. Some people don't put the first. Anytime I do scientific notation, I always put an exponent. It just helps me make sure that I truly am using scientific notation. So I always put it on your worksheet. There's a few problems where you won't see it. But there you go. What are your questions on writing in scientific notation? So we just went from standard form, regular old numbers, to scientific notation. Now we're going to go the other way. So flip to the back of your notes. Again, this is written out so you can follow along on your note sheet or you can follow along on the board. The first thing you want to do is find the decimal point. So where is the decimal point in the scientific notation problem? You also want to locate your exponent. You move the decimal point to the right the same number of spaces as the exponent with the 10. Now, I told you scientific notation you can either write really, really big numbers or really, really small numbers. In this class, we focus on only the really, really big numbers. So we're only moving the decimal to the right. Once you write really, really small numbers, you'll be moving the decimal to the left. So that's going to be the difference. But today, in this class, we're only moving right. Any questions before we get into examples? All right, so the decimal right now is behind the 9. What is my exponent?
0.
No.
1.
The exponent is a 1. So I want to move the decimal 1 space. So this in standard form would be 92.56. You move the decimal 1 space. Basically, you multiplied by 10, right? Just like in the warm-up, you're just adding a digit. Okay. In this example, we're just moving the decimal. All right, how many jumps do I want on number 8? 5 jumps. So find your decimal, jump it 5 times. 1, 2, 3, 4, and I'm out of space.
Add a 0.
So you need to add a 0 on the end. You need a placeholder. This is going to be 2, 4, 5, 1, 6, 0. Do you guys know how to find where the comma goes? You count in 3 spaces from the back. So your comma is going to go behind the 5 here. If you forget a comma, it's not the end of the world. It just makes it a lot easier to grade and a lot easier for you to check your work compared to my work when you put the comma in there. What are your questions on the first 2? All right, here's the next 2. Again, sometimes when I know I'm going to put a lot of zeros in, I write it somewhere where I know I have some free space to put the zeros in. So this one, it might be easier to write it somewhere else and then do your jumps. So how many jumps? 1, 2, 3, 4, 5. So how many placeholders do I need? 3. 1, 2, 3. 1, 1, 5, 0, 0, 0. 3 numbers from the back is where the comma goes. All right, how many jumps on number 10? 1. Again, I don't know why anyone would write 32 in scientific notation, but here it is. All right, any questions? Let's finish these off. How many jumps on number 11?
3.
1, 2, 3. So I have 7, 2, 5, 6. Then your decimal. Then your 7. So you still have a number after the decimal here. All right, and the last one. How many jumps? 1, 2, 3, 4. I'm out of space. Need a 0. 5, 7, 6. 0, 5, 0. We can count in for our comma. There you go. Technically, you can put a comma on this one too. You just count 3 spaces up from the decimal. But again, I won't mark off for commas in this class. That is the end of chapter 6. What are your questions?